Hey students, welcome back to chemistry. We are going to do chapter 4, section number 1 today. Okay, we're going to learn a little bit about the atom. So the atom is the essential element. So when a lab technician is showing using a magnifying lens to understand a lab culture, what they can't see, they try to use a devices called microscopes, which I know you're familiar with, to get experimental data. So something to magnify something that is smaller, we need to use to explore the atomic world. So there's a couple, what we're going to talk about, this section 4.1 and 4.2 are just some of the early understandings of what the atom was. The atom, as it's defined then and now, is the smallest particle of an element that retains its identity. That doesn't mean anything isn't smaller than an atom. Of course, you probably already know that there are things called electrons and protons and neutrons, subatomic particles, and even smaller particles from there. But in terms of defining and distinguishing one atom from the other atom, or one type of matter to another type of matter, the atom is used. All right, so we have used, philosophers and scientists have used this in many ways. Okay, so the first one to kind of really do that and recorded was Democritus, a Greek philosopher, and how he described atoms. There's a picture of Democritus here. And he believed that atoms were indivisible, meaning you couldn't divide them, and they're indestructible. They couldn't be broken apart or to be destroyed. So in some idea, we'll learn later that he was correct about that in terms of matter being destroyed. It can't be destroyed, it's just transferred. That's the law of conservation of mass and energy. But this idea of indivisibility, of Democritus' idea, were limited because he didn't understand chemical behavior, hadn't been thought of or invented yet or even discovered, and he lacked experimental support, which had not been brought out. That was brought out by Lavoisier in the late 18th century. So Democritus, being many, many years prior to that, just kind of gave this first idea, paint on the wall that was scattered on the wall. And so it wasn't until Dalton that really some scientific theory came around the atomic theory. Now, atomic theory, again, being a theory, it's constantly changing and evolving. Not that Democritus was wrong. He was correct for all the information that he knew. And the same thing with Dalton's theory, which we'll learn about. It was correct in all of the understanding information that Dalton knew at the time. So Dalton's theory was that all elements are composed of tiny, indivisible particles that they called atoms. So here would be element A. So atoms are made of element A. And if you had a different element, they'd be made of element B. They might be even a little bit bigger. Okay. And then if the elements were physically mixed together, say like sand and salt were physically mixed together, they could be separated like we talked about before. Or they could be chemically combined in what he called whole number ratios. Now, here's the key part that's still understanding today. When we say something like water is H2O, that is a ratio, meaning that there are two hydrogens for every oxygen. That whole number ratio was this understanding that Dalton was bringing, that chemicals and elements are together. Now, the idea of bonds weren't around just yet, so we'll say bonds now, but he wasn't talking about bonds, that they're kept together and they're never changed from one element into another element. So that was the main thing that we brought about, is going from Dalton from Democritus to Dalton, was that atoms were understandable to the point that they were individual and separate from one another. That's all for this lesson, and I'll talk to you soon. Bye-bye.